Okay, let's review some adding polynomials and subtracting polynomials. Remember, all we do to add polynomials is drop the parentheses and collect like terms. And let's collect them in descending order. That's a good idea. We see the power 2, 1, no x's, the power 2, 1, and no x's. So let's just drop the parentheses and start collecting like terms. X squared and x squared are like terms, so we'll collect these two for one like term. 3 plus 8 gives us 11 x squared. Negative 7x is like positive 9x. We'll collect them for a like term. Negative 7 plus 9 is plus 2 for our x term. Positive 23 and negative 53. Okay, they're different signs, so we know we're going to subtract them. And we keep the sign of the larger, which is negative. So we're going to make that minus 30. Now, subtract can become add as long as we change the second term. The second term becomes add the opposite. So that means we change all the signs. Negative x squared, negative x, and positive 7. Alright, after that, then we can collect like terms in descending order. Highest power of x is x squared, and it's the only one. Negative x squared. Then we have negative 7x is like negative x. There's a negative understood 1 there. So that's negative 8x. And we have our plus 8 with our plus 7 for plus 15. And that's add and subtract polynomials. Let's multiply polynomials. Alright, and we can distribute this way, or we can stack the polynomials. Some students like to do that. I'm going to show the work that way, but if you show yours another way, you should get the same result. So let's put the longer polynomial on top. 9x squared minus 4x plus 7. The shorter one, 6x on bottom, and show that we're going to multiply those somehow. Alright, and then we just multiply one term at a time, as you would numbers. 6x times 7 gives us positive 42x. Positive times negative 6x times 4x gives us negative 24x squared. 6x times 9x squared, both positive, gives us positive 54x cubed. So our result, there are no like terms to collect, and this is our result here. Okay? Alright, now let's look at some other multiplying. Here we have, this is a monomial times a polynomial. These are polynomials times polynomials. So we could stack these. It's okay to stack these. If we stack these here, they're the same number of terms, so we could stack them this way. That gives us negative 3 times 6 for negative 18, negative 3 times x for negative 3x. And then we begin to multiply with x. That's x times 6 for positive 6x, x times x for x squared, and then we can total the columns. X squared, this totals for plus 3x minus 18. Okay, and again, you can show your work another way, but you should get the same result. Alright, so let's carry out the multiplying over here. You could use some practice on this. If we stack these, b plus 4 times b minus 7, and we multiply these, the result, negative 7 times 4, negative 28, negative 7 times b, negative 7b, b times positive 4b, and b times b, b squared, and collect those for b squared minus 3b minus 28. Okay. Some of you can carry out the operation we call FOIL, and you can just do that in your head. You could say F stands for first times first, b times b is b squared, O is the outsides, b times 7, both positive, is positive 7b. I stands for insides, both positive, 4 times b is positive 4b. And last stands for the two last, positive 4 times positive 7 for positive 28. And then we need to collect the like terms in the middle for plus 11b plus 28. Okay, how about this one right here? We have b times b for b squared, b times negative 7 for negative 7b, negative 4 times b for negative 4b, and negative 4 times negative 7 for positive 28. And again, to collect in the middle, b squared minus 11b plus 28. Now I picked these three to point out that these all have b4, b7, b4, b7, but the results are different each time because the signs are different. Here we have a plus 4 minus 7, plus 4 plus 7, minus 4 minus 7. So note that just because the numbers are the same here, you have to be very careful as you multiply with your signs. You need to be secure in multiplying with your signs. Right, let's look at this multiply here. It's a trinomial times a binomial, so definitely we might want to stack this one. I left lots of room. Let's put the longer one, x squared plus x plus 3 on the top, and the shorter one, x minus 3 on the bottom. Show that we're multiplying these. Start multiplying with negative 3 times positive 3 for negative 9, negative 3 times positive x for negative 3x, negative 3 times x squared for negative 3x squared. Then begin to multiply with the x and answer under the x. X times 3 for positive 3x, x times x for positive x squared, x times x squared for positive x cubed. Total your columns, x cubed minus 2x squared. Our x terms cancel out here, don't they? Plus 3x minus 3x, so minus 9. So our result is x cubed minus 2x squared minus 9. Let's quickly look at some patterns for multiplying. Patterns for multiplying. Okay, you can FOIL these, but if you can get the pattern, these always turn out the same. When we FOIL the middle term, this gives us negative 5x, positive 5x. See, we have x, 5, 5, but 1 plus, 1 minus. So that means this is called a product of a sum and difference of the same two terms. Same thing here. Sum of a and 7, difference of a and 7. Sum of p and 2, difference of p and 2. And the pattern comes out the same every time because we get a negative 5x outside, a positive 5x inside. Those are opposites and add for 0. So all we get is our first, x squared, and our last, negative 25. X squared minus 25. And that pattern works here too. Remember, these are going to cancel out, so we just get our first, a squared, and our last, minus 49. The middle terms cancel. Same thing one more time here. This, because this is negative 2p and positive 2p, they cancel out, so we just get our first, p squared, and our last, minus 4. Alright, that's one pattern. Another pattern is when we square a binomial. Okay, many students want this just to be x squared plus 121. But remember, we're squaring a binomial, so this is just a shorter way to write a FOIL. And you can put this down twice and FOIL. If you have any trouble with the pattern, I suggest you put this down as x plus 11, 2 factors of x plus 11. And then FOIL that, where you get x squared plus 11x plus 11x plus 121, and then collect your terms for x squared plus 22x plus 121. Okay, and hopefully then you can start to get the pattern down. The pattern here, we're going to square b, and then we'd have two of these, so it'd be b times 3 and 3 times b. That's 3b and 3b for 6b, and then we're going to square 3. And remember, if you have trouble with the pattern, go back to FOIL. So what if we had x minus 11 squared? Well, it's going to be this same pattern here, except that the middle term will be negative. It would be x times negative 11 and negative 11 times x. So we'd have x squared minus 22x. Still be a plus 121 because we'd be squaring negative 11. When we square a negative, it comes out positive. Alright, so what about the pattern here? We'd be squaring b. We'd be multiplying b times negative 3 2 times, so that's negative 3b gives us negative 6b. And when we square negative 3, again we get a positive 9. So those are the patterns of sum times a difference for a difference of squares. And the square of a binomial always comes out trinomial.